So, hi to all. Today we are going to begin with a new segment, that is oceanography. Okay, there are 4 parts of physical geography. One is geomorphology. Right? We have completed this part. Now, oceanography, then we will do climatology, then biogeography, right? So, geomorphology also extends to this part regarding the relief of the ocean basins, right? Because you know that oceanic basins are also, they are also a part of the same crust, right? Because all the features, all the landforms of the oceanic basins, oceanic floor area, they are also the part of the same lithosphere. So with the same principles of geomorphology, we are going to understand these relief features. So today we will study about the relief, means the topography. Wherever the word comes topography, okay, topography means the ups and downs, different heights of landforms. Okay, they are called, in a word, topography. So we are going to study the topography of the oceanic floor as well as the temperature and salinity patterns of the oceanic water, both. Okay, because through understanding the temperature and salinity patterns, we are going to better understand the circulation of oceanic waters, right? Because in your prelims examination, every year UPSC asks 1 or 2 questions from oceanic water. Okay, oceanic water circulation system, that is your oceanic currents, and possibly 1 or 2 question also from the temperature or salinity pattern of the oceans. Okay, and one more thing, the relief feature of the oceanic basins is also important regarding the topography, and it will also help you to better understand the oceanic mineral resources, right? When we will study the human and economic geography part, there you will study about the oceanic minerals, like minerals of the Indian Ocean, minerals that you can find in the Indian Ocean region. There is also geopolitical rivalry over these resources. You know that China is pushing its powers towards the, not only in the south, South China Sea, but it also want to have some stake in the Indian Ocean region, because the Indian Ocean region is very rich in strategic minerals. Yes, okay, right, like cobalt, like magnesium, like zinc, and other rare earth minerals as well as. Okay, so first topic will be the relief of the oceanic basins. So what is the relief or topography? Like you are coming from this part, this is your continent, right? Here from you go towards this part, this has a very less slope of 2 degrees, average 2 degrees. Okay, this is known as the shelf area. Continent word is attached with it. Continental shelf. They are known as the continental shelf. Then this slope area comes, and this is known as the slope. Continental slope. Then this area of rise. So the oceanic floor, you can see here that up to this extent, They are known as the continental part. Means continental shelf, continental slope, continental rise. Okay, shelf has very less slope, 1 to 2 degree. This slope area, it has around 5 to 7 degree slope. Then again, the same type of slope like shelf, it is here in rise part. So after that, you see that there are trench areas. Such type of areas, they are known as trench areas. They are known as oceanic trenches. So here the word comes oceanic. Means the real oceanic floor starts from here only. Up to this extent, it is continental part. Though it is covered by it is submerged under the water. That is why it is part of the ocean. Right? Here, water is all over here. So this is your lithosphere. This is also lithosphere, right? This all part is lithosphere. This pair of solid rocks is simply called lithosphere, right? So how these trenches are made, you know, through plate tectonics, that because of the subduction of the oceanic, plate, this part of the continent is dragged, and a particular deep landform is made. That is known as the oceanic trenches, and they are the deepest parts of the oceans. Okay, trenches are the deepest parts of the oceans. You know, many trenches, like in Indian Ocean, you know, there is Andaman Sunda Trench. Okay, there is Sunda Trench, there is Java Trench. Okay, in the Indian Ocean region, and in the Pacific region, you know, there is Tonga Trench, Kermadec Trench, Kuril Trench. Yeah, I will write. And there is Mariana Trench. It is a well-known trench. Which is the longest trench in the world? No, it is the deepest. Longest trench is Peru-Atacama Trench. The trench alongside the coast of Peru. It is known as the Peru, Chile, or Atacama Trench. So these are some factual informations. So after, like you were here, you came here, you got into continental shelf area, then slope area, then rise, then you went deeper into the trench area. Then again this vast plain starts. Means like you can find mountains, plateaus, and plains on your continental area. Just like that, here you can find also the mountainous mid-oceanic ridge areas. Okay, some of the plateau areas are also there, especially in the Pacific Ocean. You can find some of the large plateaus like Albatross Plateau, right? And here are vast plains. Means these plains have a vast area. They cover the largest area of your oceans. These abyssal plains, they are known as the abyssal plains. Abyss means that is very deep sea plains. You can see that they are the deeper parts of the oceans, not the deepest are the trenches, but they are the deep plains. Then as you go further, you will see here such type of ridges. They are known as the mid-oceanic ridge areas. This central part there is a rift, and it is known as the rift. Sometimes it can be called rift valleys of the mid-oceanic ridge system, because there is a crack, there is a fissure through which you know that different type of magma will arise here. You know, these are the areas where there is a continuous chain of volcanoes, though they are not very large and cone shaped. They are very low height volcanoes, but you can find these volcanoes along the long stretch of these mid-oceanic ridge areas. So this is the magma coming out from here, and in this way the floor spreads, the sea floor spreads in this way. So this is the manner this is magma, right? On these floor basins, especially abyssal plains, you can also find some conical mountains. They are called sea mounts. Like here, you can find some of the mountains like this. Some of the mountains can go even like this, and they will look like an island, right? Like Azores Island, like Iceland. Actually, Iceland is a part of the mid-Atlantic ridge system, where mid-Atlantic ridge rises above the seawater. So they can look like an island. This is a sea mount. And when any sea mount is eroded away, means its upper part is eroded away, it will be like this tabulated form. This is known as buoyant, right? So such are the features of your oceanic floor areas. And through the same plate tectonics, you can understand that how these landforms would be formed, and they can be changed. Like first it was a sea mount, but later on its upper part was eroded away through the oceanic waters activity, exogenic activity, erosion, etc., and it has become a buoyant. So we will study such type of relief features in all the oceans, like in Indian Ocean, Pacific Ocean, and Atlantic Ocean especially. Okay, because questions may be asked in a factual manner, like this particular plateau, like Albatross Plateau, where is it located? Okay, so through a slide, we will see here few more terms like cryosphere. You know the hydrosphere. Hydrosphere is the meltwater part of the earth. That is known as hydrosphere. But all the snow, all the ice caps, okay, ice sheets of Antarctica and Arctic, and all the icebergs, they are part of the cryosphere. Okay, so along with hydrosphere, there is also a cryosphere. Okay, and they are all part of hydrological cycle. So you can see these relief features in this map. Here they are mountains. This is the continental part, right? This is the margin of the, this area is the marginal part here, where continents and oceanic areas are, yeah, they are meeting. This is the estuary. You know that. What is the difference between delta and estuary? Don't? Yeah, particular triangular shape. Yeah, delta has a particular triangular shape, but estuaries are somewhat open. Yeah, open and wide and deep. Okay, wherever there is a dearth of sediments, there are chances of estuary, dearth of sediments. Means there are no sediments or very less sediments. Like the rivers of Narmada and Tapi. They are flowing in such a rift valley where they can find very less sediments. The rock is stronger and their cutting power is very low, because they are not coming from a high mountainous region like Gangetic rivers, like Himalayan rivers. Okay, so Narmada and Tapi both are flowing in a great rift valley. So in the rift valley system, because it is a rift valley system, it has more cracks, and some of the cracks are larger. So whatever sediments, if they have, they fill those sediments actually on those cracks during their course, and they are not able to carry those sediments along with the water up to their means mouth areas. Okay, where they can deposit the sediments, because all the sediments they have already left over those cracks of the rift valley systems. So whatever amount of very small amount of sediments they have up to their last journey, so that sediment is also actually mingled with the oceanic water as soon as it reaches the oceanic area, Gulf area, that is Gulf of ഖംഭാത്ത്. And there you know that Gulf of ഖംഭാത്ത് has very high tides. It is a tidal zone. So whatever amount of sediments it has, those tidal waters, they bring it away and mix with the oceanic water. Means there is no chance of delta formation there. For delta formation, first a river should have a greater amount of sediment load, then its mouth should be like this. Means if this is a river and this is the sea. Okay, if goes like this, means the sea level is above its mouth, then there are less chances of delta formation. Means its mouth should be above the sea level, so that it can deposit the sediments first there, then it will make distributaries over those delta formation, and then it will dive into the sea. Okay, this is the whole mechanism of the delta formation. But in the estuary, like in the Narmada, like in the Tapi, like in the Zuari river of Goa, they go just and meet the sea in this manner. Okay, very less amount of sediments, and that very sediment is also mingled with this tidal water, because their mouth is below the sea level. Okay, that is why these rivers are not able to make delta. Okay, a very beautiful question can be asked about this concept also. So, and here you can see canyons, some of the canyons. You know that canyons, you can find those canyons in the continental part. Like I have already discussed that. Where are the conditions of canyon formation? No, that is gorge. That is the condition of gorge making. It has some climatic factor attached with it, like Grand Canyon of Colorado River, USA. It should flow in a semi-arid or arid zone first. Okay, for canyon formation, because canyon are not like this V-shaped, they are broad like this. Okay, and to pluck these sediments out the region and to widen the valley by the exogenic factors, the region should be arid or semi-arid. Yeah, the climatic factors are there. Okay, for canyon formation, but this canyon is submarine canyon. Here on the margins of the oceanic areas, you can find some submarine canyons. Write down these things, very important for your exam. Submarine canyons, they are means their features are just like the canyons of the continents. Anybody is asking, sir? Where estuary is open and wide with well flow? Puja. Okay. Yes. So canyons, submarine canyons are there, and they start from the continental shelf area to the slope up to the rise area. And it is believed that means many type of theories have been put forward for these submarine canyon formation. And it is believed that they are either made by some eddy currents. They are also known as turbidity currents. Turbidity currents. These submarine canyons are formed by eddy currents or turbidity currents, turbid water, you know, turbid waters, turbidity currents. The turbid waters of the rivers, after their delta formation, the river water still has a lot of sediments while going under the sea. Okay, so like Ganga river, after making the delta in the Sundarban and Bengal region, it goes deep into the sea. While going deep, it has a lot of sediments with it, and the current formation is like this. Means while it would be going under the submerged part of the sea, the current formation is like this, and in this manner, this is cut deep. This part is cut deep, and such type of canyons are formed. It is a theory. It is a hypothesis, you can say. Turbidity currents mean the turbid waters of the rivers, and in a particular manner, they are flowing like this. Like you can assume this river water is coming from here, and while it is going under the sea, it will make the momentum will be like this. Okay, and in this momentum, it will cut through this part of the continental shelf and continental slope part, and it will make such type of deep canyons all through the slope area, continental slope area. Okay, so this is one hypothesis, and there is also an hypothesis that these submarine canyons would be formed by some submarine underwater landslides. Like because of some upheavals, because of some tectonic movements, some parts of this continental shelf area and slope area, they might be broken in a landslide manner. So they might be formed by submarine landslides also. Okay, so all these hypotheses have been put forward for these submarine canyon formation. Right, here you can see that this is the fan, like the alluvial fans were made where the river, when it was coming from the mountainous course to its plain course, when river like Himalayan rivers, when they downslope from the Himalayan areas to the Ganga plain, on the margins, such type of, on the margins of the mountains, on the foothill zones of the mountains, such type of alluvial fans and cones are formed. In the same manner, here in the continental rise area, such type of fans are formed just below these canyons. Right? So the same type of landforms are there. Like you see in the continents, they are underwater. So this is continental rise. Then this is the vast plain that you call the abyssal plains or deep sea plains. In this plain area, actually these trenches are shown here. They are here. Mostly they are here on the margins of the continents. Okay. Then some of the hills, like such low hills and seamounts. Okay. Such type of volcanic islands, atolls, goyards like this Table Mount, and this type of rift valley in the mid-oceanic ridge area. Such type of landforms are being made. Right? Understood? So largely these four features: continental shelf, slope and rise, oceanic deeps and trenches, and deep sea, deep ocean floor. You can see here also the same. Now come to this map part. Okay, we will study each and every ocean one by one and their features. I should start from Indian Ocean, I think, because Indian Ocean is more important. Bottom relief of the Indian Ocean. You can see here in this map that this is the all Indian Ocean basin. This is the Central Indian Ridge. This system is called the Central Indian Ridge, like the Mid-Oceanic Ridge. This is the Mid-Oceanic Ridge system of Indian Ocean, and it is in the central part of the Indian Ocean, like this Mid-Atlantic Ridge. This is the Central Indian Ridge. This central part of the Central Indian Ridge is called the Central Basin, and there are two branches of this Central Indian Ridge. One branch is Socotra-Chagos Ridge. One branch is Socotra-Chagos Ridge, and another branch is Lakshadweep-Chagos Ridge. I think now it is more visible. This part, this particular part, this part is Socotra-Chagos Ridge, and this part is from here, up from here. This is Lakshadweep-Chagos Ridge. Okay, this whole ridge system is called Central Indian Ridge. And you can see here there is a plateau also. As I told you, there are plateau parts in these ridge systems. This is known as Amsterdam-St. Paul Plateau. Amsterdam-St. Paul Plateau. Here, this is also a ridge system, small ridge system, South Madagascar Ridge, and its southern part is called Prince Edward Ridge. This part. This is also a ridge system. Ridge system, as you know, that ridge systems are the part of the diverging boundaries, where from the magma is coming out, right? Means magma is coming out in this part, all through this, and it is, the sea floor is spreading in this manner. This sea floor then will go under this continental part, continental plate, along these trenches like Sunda Trench. Understood? Here in this part you can see that there are no trenches because this part is not active. Means this part and this part, they go in tandem, they go together. There is no subduction along this boundary. Subduction is only here. It is centered over here. Okay, means this all part go in completion. This oceanic and this continental plate go together. They flow together. Right? So there is also a trench part, this Sunda Trench. This is also a small ridge, Andaman Nicobar Ridge, where our Andaman Nicobar Islands are located. Here our Lakshadweep Islands are located in this ridge system. Means both our islands are part of this ridge system. Okay. How islands are made? Means some of the parts of the ridge, they are so high that they are above the water and they look like an island. Okay, just like Iceland, just like Azores Island, just like Andaman, Nicobar, these Lakshadweep. Yeah, actually, they will not move in that manner because there is no such, you can say, sea floor spreading occurring over here. Okay, actually, islands are the part of this ridge system only. Okay, they are always there. That is why there is a continuous volcanic activity here in barren island area. Means islands will be always there because a new magma will be coming out always. Okay, if it would have been an intraplate volcanism like Hawaii, they are actually not the part of the ridge system. They are far away from there. So when this, for example, if the islands would be here, okay, and this part of the oceanic floor would be moving in this manner, then island would move like this. But they are not the part, because this part is not moving. Means only here the plate is going under this continental part. All this part is not so active. Means you can say that though magma is coming out, but in very small amount from here. It is not a very active. That is why the sea floor spreading is not the same. It is not in the same rate in all the oceans. Some of the oceans, they are means their sea floor is spreading in a speedy manner. In some of the oceans, it is very slow. Slow means the tectonic activity is very, it is very low. Magma is not coming out in that very manner. Okay. So this is 𝐶𝐶𝐻𝐿's ridge. This part, this small part is 𝐶𝐻𝐿's ridge. This is Reunion, Mascarene ridge. This is 𝐃𝐨𝐰𝐧𝐥𝐸𝐬. Ridge. Okay. You can, this is, it is not visible. 𝐃𝐨𝐰𝐧𝐥𝐸𝐬 ridge. This is 𝐶𝐻𝐿's ridge. The 𝐶𝐻𝐿's islands are parts of this ridge system. And there is one more ridge. It is not shown here. Here is a ridge that is dividing this part of the ocean in two parts. And this part, this ridge is known as the 90-degree east ridge. You can also write down this ridge. There is a ridge over here, and it is known as 90-degree east ridge. Just like that. Okay. Try to draw these maps on your own. So there are one important ridge is Central Indian Ridge. Its southern part is Amsterdam-St. Paul Plateau. Then it is branched off into Socotra-Chagos and Lakshadweep-Chagos ridge system. Then alongside its means on the eastern part of it, there is 90-degree east ridge. Why it is called 90-degree east? Because it follows the meridian of 90-degree east. Okay. On your atlas, you can see it. Then alongside its, there is Sunda Trench. This is also known as Java Sunda Trench. Then here some of the basins or the deep, you can see that they are just like abyssal plains. Basins are like the abyssal, deeper parts of the abyssal plains. Like they are the upper part of the, they are the mountainous ridge part of, they are the deeper parts of the oceanic floor, right? Then here, this ridge system is important, and these two ridges, Carlsberg Ridge and 𝐶𝐻𝐿's Ridge. Okay. Here you know that this is the Arabian Sea Basin, right? So should we move forward now? So they are just, you can see they are just the names. The landforms are all the same. Means those are channels. Channels means where from a ship can cross the waters. Yeah. Means channels are just, they are the water part. They are not the part of the topography. Okay, where from a ship can cut through. It can pass by all the channels. So in all the oceans, you can find these landforms, means the same landforms, the ridge systems, the basins, okay, only the names would be different. So you have to memorize those name parts. Okay, like where is it? Like where is Sunda Trench? There are so many trenches. Yeah. Yeah. So you have to locate them on your map. That is the practice part. Okay. Like this is your Atlantic Ocean. In Atlantic Ocean, you can see that in the mid part of the Atlantic Ocean, this is this S-shaped mid-Atlantic ridge system. Okay. Like there was a plateau on the southern part of the Central Indian ridge. There is also a plateau on the northern part of the mid-Atlantic ridge. It is known as the Telegraph Plateau. Important for your prelims. Yeah? No. Not all these. Division. Map. Actually, I'm just saying that you have to memorize these names of the plateau, of the ridges. Okay, like there was 90-degree east ridge. So 90-degree east ridge is the part of Indian Ocean. Okay, here mid-Atlantic ridge and the northern part of the mid-Atlantic, like here, I was saying that this Amsterdam St. Paul Plateau is part of the Central Indian ridge. The southern part of Central Indian ridge is known as Amsterdam St. Paul Plateau. Okay. In the same way, the northern part of mid-Atlantic ridge is known as Telegraph Plateau. They are just names, but you have to memorize them. They are important for your prelims. Okay, in prelims, location-based questions are being asked. So a question may be asked not only from continental area, but also from the oceanic area, that where is the Telegraph Plateau located? Yeah. That is why I'm telling the names of important features only. So, like write down this Telegraph Plateau. Yeah, it is located on the northern part of the mid-Atlantic ridge, right? Then this mid-Atlantic ridge system, this whole northern part of this mid-Atlantic system is known as Dolphin Range. Dolphin Range is the name given to the northern part of the mid-Atlantic range. Oh, sorry, ridge area. This is all mid-Atlantic ridge. Its northern part is this Telegraph Plateau, right? And the northern part of this, there is a deep between the northern and southern part of the mid-Atlantic ridge. And this deep is known as Romance Deep. Romance Deep means there is a cut. So Romance Deep, so northern part of the Romance Deep is known as Dolphin Range. This all range, this is just like a mountainous ridge system, and the northern part is known as the Dolphin Range. Okay. So this is longest ridge. Yeah, this is the longest ridge in all the oceans. Deepest means this is the ridge. They are not the deepest parts of the oceanic areas. Though their mid part, their central part is like a rift, like a crack, but they are not the deeper part. Actually, they are the higher parts. They are ridges. They are like a mountains. Okay, and its southern part is known as the Challenger Ridge. The southern part of the mid-Atlantic ridge is known as the Challenger Ridge. Okay, northern Dolphin Range, southern Challenger Ridge. It can also be called Dolphin Ridge. Okay, means this mid-Atlantic ridge is divided into northern and southern part. Northern part is called Dolphin Ridge and southern part is called Challenger Ridge. And in between the two, there is Romance Deep. Its extreme northern part is like a plateau named Telegraph Plateau. Right? There are some of the branched ridges like this Walvis Ridge. They are not so important though. Okay. Only write down the important features. Yeah, now come to this basin part. This is also important. This is known as the 𝗂𝐻𝐻 basin. Basin or they are the somewhat deeper parts of the oceanic floor. 𝗂𝐻𝐻 basin. Here it is Angola basin. Here a current flows named 𝗂𝐻𝐻 current. With the same name, here a current flows, oceanic current flows with the same name, 𝗂𝐻𝐻 basin, 𝗂𝐻𝐻 current. Okay. Here the basin part is known as Angola basin, because here a country named Angola is here in African coastal part. Angola. Yeah. Here this part of the basin is known as Brazil basin, because this is the alongside of Brazil. This part of basin is known as Argentine basin, because here it is Argentina. This part of the basin is known as Guyana basin, because here there is French Guiana. There is a country named French Guiana in South America. This is North American basin. This is West European basin. So they are important features. Along with them, there are some trenches also. Though, just like Indian Ocean, Atlantic Ocean also has a few trenches, because here in this part, the oceanic plate is not subducting or not undergoing the part of this continental plate. That is why here you will find no trench. Trenches show that here a particular part of plate is undergoing, yeah, it is subducting under another plate. So there is no active plate boundary here, you can say. A plate boundary might be, but it is not active now. In some geological time, it would be moving. Yeah.
So this ridge is formed by converging or diverging?
Ridge?
No, this Atlantic.
Ridge.
Atlantic ridge is formed by converging or diverging?
Yeah, you tell me.
Converging?
No, they are the diverging part of the boundaries. Okay, because here from the magma is coming out and it is flowing in this manner. So it is the diverging boundary. Na? Like this is a oceanic plate. Okay, magma is coming out from here and it is flowing in this manner. So here you can see the divergence. Okay, only in this manner the magma is coming out and it is flowing like this. This ridge is being formed. Okay, so they show the diverging boundaries. Okay, and trenches are on the converging boundaries. Where there are trenches like this Puerto Rico trench, this Cayman trench, here in southern part, South Sandwich trench. Trenches show that there is the convergence of plates. One plate is converging towards the other, and the heavier plate is going underneath the lighter plate. Understood? So here are very few trenches, and all the trenches are on the western part of the Atlantic Ocean. One is Puerto Rico trench. All the three trenches are important for your exam. Puerto Rico trench. Here is an island named Puerto Rico. The trench is named after that island, Puerto Rico trench. Here are Cayman Islands, so it is called Cayman Trench. Puerto Rico trench, Cayman Trench, and here on the southern part of the Atlantic Ocean, here is South Sandwich Trench. In the extreme south, South Sandwich Trench. This trench part is known as South Sandwich Trench, right? With these maps, your map part will be somewhat stronger, okay? Because you see your atlas, but there is more confusion because a lot of features are written over there, okay? All the important and unimportant both. Here you are focusing only on important ones. One second. Yeah? Yeah, two oceanic plates are diverging, है ना? Volcanoes ही volcanoes है. In along all the parts, they are volcanoes. For volcanoes, only the magma is needed. Actually, magma can be formed by two manners. Means either there would be a high temperature area and rocks would be melting. The molten material, molten rocks are simply called magma. Okay. Actually, in these areas of mid-oceanic ridges, there is always, you can say that there is always a source of magma underneath. So magma also always comes out, and it is a basaltic type of very thinner type of magma. Means it flows easily. It flows very easily. That is why it gushes out in a silent manner, not in an explosive way. Okay, like the thicker magma having more granitic material, having more silica. Okay, it is not that much thicker here in mid-oceanic ridges part. So it comes under the silent fissure eruption. Yesterday I have discussed two types of eruptions. One was central explosive and the other was silent fissure eruption. So they are under the silent fissure eruption. Means magma is continuously coming out but silently. Okay, you can see that there is no conical shaped volcanoes there, but volcanoes are there. They are not conical shaped. Okay, they are not so high. There are two terms, volcanism and volcanoes. Here volcanism is, but no true volcanoes. Volcanic activity here. Okay. So we have completed this Atlantic Ocean part. Now come to this bottom relief of the Pacific Ocean.
Introducing the Prelims Target course and Prelims Test Series at ProdEgyIAS. Designed for UPSC Prelims 2026, this comprehensive program offers in-depth classes on history, geography, science and tech, environment, polity and governance, and economy. Stay updated with current affairs and sharpen your skills with our Prelims Test Series consisting of 50 full-length tests covering all subjects along with CSAT. Join ProdEgyIAS and stay ahead.